Hey PCWorld fans, Adam here at the Intel Overclocking Lab, hanging out with Dan. Dan, for the folks at home, tell them your title here at Intel and what you do.
Yeah, I have the pleasure of working on overclocking at Intel. So my title is Chief Overclocking Architect.
That sounds important.
It's
so
fun.
I got to tell you, when we set up this appointment to come check it out here at the Hillsborough campus, I assumed I was going to come in here and music's going to be blaring. You guys are hitting the keg, just like, oh, I got a new world record over here, but that's not how it goes here, is it?
Not every day.
Not every day.
Yes.
Oh, okay. Not every day, but sometimes. Okay. Well, yeah. I mean, the real question, the serious question is, I guess I didn't understand why Intel would need an overclocking lab. I assumed it was to try to push everything to the bleeding edge. But that's not the case. Why?
Yeah, a lot of overclocking is experimenting and exploring, and how much more headroom could we get in this subsystem? How far could we push the cores? How far could we push memory? But that sounds like fun and games for overclockers today, but what we find time and time again is that today's overclocking achievement becomes tomorrow's base product capability. It becomes in spec because somebody has to do that exploration to see just how far can we push it? How much headroom do we have?
So in the lab here, you have a whole team set up. What kind of stuff are you working on? Desktop, mobile, RAM? What are you overclocking?
Little of everything. So desktop is our main focus, but we
Okay.
also have a mobile line of overclockable parts as well. And yeah, this lab is responsible for the worldwide extreme memory profile technology program. So all those XMP memory modules you see out there come through this lab.
Okay, nice. And so how early do you get involved in a product's life cycle? So take something like Air Lake 8S. Hey, when do they call you up and they're like, hey, we got this new product. We need you to do something.
Really early. In fact, this is
Really?
an exciting thing about this function is we start at time zero. It's from inception of a new product. So they say, hey, we got a processor we're going to do 5 years out. Let's start thinking about overclocking for the reasons we just discussed, which is if we plumb it just right so that we have them to maximize our overclocking capabilities, that's where we get the best results. So I'll give you an example. We're designing a new memory controller. How high should we have the registers be logically addressable for? So should we allow for 20,000 mega transfers, or what number should we pick? So that's an example. You have to architect these capabilities really 5 years in advance. There might be a new power management algorithm, and we have to make sure that can be adjusted to allow full overclocking. So those are the kind of things you do 5 years out. And then all the way through first silicon, our team will be in the lab powering it on and testing the OC functions. And then all the way through release, there's some work even with the customers, training the motherboard vendors, the OEMs on how to use the OC features. And then finally, doing maybe some workshops with the end overclockers in some cases.
Yeah, so I mean, when I think of overclocking, I always think of those overclockers that are hitting world records and stuff like that. But it's almost like what you guys are doing here is more validation than like trying to hit records, right?
Yeah, we certainly love records, and that is part of it. But the day-to-day job is, making sure all the overclocking capabilities, the knobs, they're all working and functioning well. And then looking for new areas. So we call that opportunistic upside. So we might find some area that we didn't think of 5 years ago that, hey, this is a new opportunity. Let's seize that. So that's another thing we would be doing in the near term.
And so this lab, I mean, this is one lab of many. It sounds like you guys have a worldwide operation. This is outfitted with actual water supply up and down the benches.
Yeah, it's pretty exciting.
Tell me about that setup.
Yeah, we have a house water system that brings in already relatively cool water, and then we can actually cool it down further from there in case we're trying to really hold something near 0 C, for example.
Wow. And so it's like everything's tied, all these platforms, all these systems are tied in, and they can be accessed remotely. You showed me the setup for the remote overclocking stuff. Why? It seems like it wouldn't be as fun to just remote into something rather than being there.
I mean, it's hard to beat the hands-on, but Intel being such a big worldwide company with seeking out the best talent from all over the world, we may have an expert in Israel that is doing deep debug in a certain area, or a different expert in India, or someone in Malaysia, all over the world. And so it's a great way to bring those folks together. It's something in the last 5 years that has really grown, and it's helped us solve challenges more quickly.
Nice. Okay. And do you have to develop your own in-house tools to test these things, or are you just using, Cinebench and just letting it rip?
Yeah, I mean, we use both existing tools like benchmarks, but also, yeah, we do develop our own. So there's all kinds of overclocking software out there. Each motherboard vendor has their own, and OEMs, and we have our Intel Extreme Tuning Utility software for consumers. But inside, yeah, we develop our own version that can run special scripts or special tests that maybe wouldn't be on the production version, which is also fun because we get to kind of see the inside.
Yeah, well, you mentioned that official Intel app, the XTU is kind of what it's short for. How much involvement do you have in helping lay out some of those features?
Yeah, it's a partner team and we work together, and a lot of times we'll have defined a new overclocking feature or an opportunistic item we find, and we'll work with that XTU team to implement a new control or a knob in it. As an example, one-click overclocking has been kind of popular, right? I don't want to guess about how these settings should be. I just want one button that gives me some result. Mm-hmm. So one of the features that the team here works on is the Intel Speed Optimizer feature, where we've pre-profiled for your processor what the most likely overclocking settings should be. And the user just goes into XTU and does the one click. So that whole profile is built here in this lab. Oh. And that's an example of that partnership.
How accurate is that? I always feel like it's probably not as accurate as somebody going in and manually doing it, but yeah, what can you expect?
Yeah, you're right. So if you were to tune it by hand, you can absolutely get that last ounce of performance out of it. But it maybe 50 to 70% of the available headroom is there. So the way you create a profile like that, if you want, it's really a one-size-fits-all profile. So let's say you have 100 units and you test them all, and you find out, okay, all the units could at least achieve this frequency. So that's would be your starting point. So if you know everybody can do that, just snap right to that starting point. So if your lottery, if you look at a processor as a lottery ticket, maybe your unit has even more OC headroom. By hand, you could extract that as well.
Wow. Okay. And what about working with motherboard manufacturers? So there's a lot of tools inside a motherboard BIOS or UEFI to overclock things. How much influence do you have over that setup?
Well, that's one of the great joys of the job is working with customers, our engineering partners at every motherboard vendor. We have some influence there, but I want to give them credit. They are innovative. These folks have a deep engineering capabilities and a passion to, again, find and expose that every last ounce of performance. So they're doing that on their own, but the way we work together is we share, hey, here's a new feature we have, and this is how you could use it. Or they might say, hey, have you thought about doing this? And we'll say, it's a good idea. Let's add that feature for you. So we work with them very closely, and they're our cherished partners, really.
Huh. Okay. I met a lot of your team here. Does anyone here currently have a world record in something?
Yeah, actually, I'm pretty proud of one of our team members, Dave, who has been an extreme overclocker, and that's how we found him. Actually, he's close to Intel, and we said, hey, would you like a job? Come join us.
Nice.
And that's literally how we.
What's the record?
Oh, Dave has got a lot, but he also specialized in graphics overclocking and CPU overclocking. I think a little of everything.
Do you do graphics overclocking here as well? Or is
we
it
do.
Just
So
processor?
our processor graphics, so the integrated graphics in the processors can be overclocked. And you might say, well, why? Well, in notebooks, that can be interesting if that's your primary graphics solution.
True. Okay.
Yeah.
Two final questions. Number one, if you had to tell people one thing at home, why overclocking here in this lab matters, what would that be?
I'll go back to what I was sharing before. I truly believe that today's overclocking and that overclocking achievement is tomorrow's in-spec product capability. And over again, that has come true. So you'll see that on our next wave of desktop products that come out. So that's why I love it.
Okay. Last question then. Why is undervolting better than overclocking?
Undervolting, which by the way is considered an overclocking feature, so it exists on overclocking SKUs. Undervolting is great because it lowers your thermals, lowers your powers, and ultimately increases turbo residency. It's very, very simple, and it's a great feature.
Well, I think that's I'm leading you here because I like undervolting in my systems. But yeah, I think a lot of people would think that it's counterintuitive to undervolt, that you're actually limiting yourself, but it's not the truth, right?
Absolutely. Yeah, it is not the truth. Undervolting is great. In fact, some undervolting is actually built into overclocking itself, because You don't have to go at the same voltage trajectory that we have for our in-spec frequencies when you overclock. So sometimes you can actually overclock and not raise the voltage. So that kind of proves the point there. A lot of people in mobile have enjoyed undervolting because the thermals and the power are amplified, right? You get to add battery life to the mix.
You heard it here first at the Intel Overclocking Lab. I appreciate chatting with you, Dan. Thanks for taking me through all the stupid questions I have as an overclocking noob. And thanks everybody for watching. We'll catch you in the next video.